am Rostacia, a Yale PhD graduate. I've built an interactive visualization tool that allows organizations to assess their GitHub repositories to help them decide which of the repos should be archived. I've deployed this dashboard for Brown University's CCV's GitHub, where you can adjust the number of stars, forks, open issues, and watches. By adjusting these sliders, you can change the criteria of the repos that you see in the table. If you change the date range for the last update date, which is just the last date someone pushed or committed to the repositories, you can adjust the repos that you see in the table. So if I change this last update date from April 2016 to, let's say, July 2017, you can see dynamically adjust the repos you see in the table. This is a responsive bubble chart that displays the repositories according to their last update date and the number of open issues. When you hover over a bubble, you can see the specific data of that repository. Each bubble represents a repo, and you can see its last update date, number of open issues, and days since the last update. We also have a histogram for the distribution of stars, forks, and watches across repositories. So we can see how many repos with 0 stars, 0 watch, forks, 0 watches, and going down the line, we could see the various counts for all of these metrics. This histogram is also very interactive, so you could isolate which of the metrics you see by clicking on its name in the legend. This repo that we see all the way on the right, you see it has both 28 watches and 28 stars, so that's probably a very popular repo. This would be one of those repos you don't want to archive because it's popular, one of the more popular ones. So these 3 histograms individually look at the number of stars, forks, and watches across repos, and if you hover over the bar, you can see the names of the repositories with 0 stars, 2 stars, etc. And we can see that there are a lot of repositories with 0 forks, stars, and watches. In order to get the data to create these visualizations, I connected to the GitHub API, which gives you real-time data from GitHub's databases. Before I wrote any code, I tested the GitHub API endpoints I was interested in using a tool called Postman. So opening a new request in Postman and entering the URL for the GitHub API endpoint I was interested in. Specifically for this one, I'm looking for an overview of all of the repositories at Brown University, and clicking send, we get a JSON list of repositories with all their details. I use the Plotly graphing library for Python in order to generate the bubble charts and histograms for my visualization. This, for example, is an overlaid histogram, which is similar to the code that I use in order to generate the histogram with all of the stars, forks, watches, all those metrics in one chart. I also created the bubble chart using Plotly Express library, and that's how we get the really nice visualization, interactive visualization of the number of open issues and really old repositories. I use the Dash framework in order to deploy a web dashboard for these visualization tools. I also used it to create an interactive dash table that you can sort in alphabetical order and in ascending and descending order by the number of stars, forks, watches, and open issues. I was able to create really interactive visualizations to help Brown CCV decide which of the repos to archive. I was able to create sliders to look at different ranges of stars and folks and watchers that the organization might be interested in specifically archiving. I was able to create really nice bubble charts, interactive histograms that you can click on and hover over and see the names of repositories. So this was a really fun project. I hope you like the visualizations. Thank you for watching. Please let me know if you enjoyed this project and if you have any suggestions for any other project you would like to see me build. Thank you again and see you again next time. Goodbye.